Can you hear me? Oh, good.
Hello. Is this Computer Science 101? Are we in the right place? Did we go in the right place?
I don't think so.
Oh, this is the other one.
I think it's our session.
Yeah, this is our session. OK. Hey, everybody. Hello. Hey. There you go. That's what I want to hear.
Well, my name is Tetyana Sych, and we are happy to see you here.
That's right. My name is Nikola. I'm a software engineer. And hopefully, with this session, we want to make sure that you can learn about AI from a practical standpoint. What are some of the things that you can do with AI for real inside of your Windows applications, right?
Yeah.
Can you see the next? That's right. So I'm sure many of you have already been asked to add AI to your application by your boss, by your friends. So hopefully, this is going to help you actually do that for your applications. And the best way to learn is to see what others are doing on Windows.
Absolutely. And there are a lot of partners, and internally in Microsoft, we're using AI a lot. But why? Why are we using AI? There are so many different reasons why would you do that. And one of them is, which is very obvious, is enhancing user experience, like chatbots, or just taking over some routine tasks, like, for example, maybe data entry.
Right. For example, Be My Eyes is a great accessibility application. They use large language models to help people that are not able to see or have low vision to actually see things like charts, pictures, screenshots. They even help set up your environment for lighting for things like Teams calls, et cetera.
Or, for example, DaVinci Resolve Studio, which is pretty famous in Hollywood for their role in old Marvel's movies. And with their magic mask that actually working on NPU, they can run it 3 times faster.
And DJ Pro is a very popular application for hobbyists and for professionals as well for mixing music. And they're using the NPU on the latest Copilot+ PCs to do things like neural mix, which allows you to separate a lot of the different parts of audio to do really cool stuff with those things, or to find things like the BPM to mix tracks easily between each other.
Yeah, absolutely. Sounds amazing. I would love to mix my music on my personal laptop.
What's stopping you?
Nothing. So this is just first day at Build. And it's been overwhelming to hear how much Microsoft invests in AI. So in this session today, we're going to be focusing on a few things. We're going to be building an app just together, just Nikola and I, actually. But we're going to be using some of the things that have been announced already, like APIs that you can use to add your experiences to your app, or some frameworks and tools that will be announced that you can use to build your apps.
Right. Now, you might have noticed we're kind of matching here. We tried to dress up as students.
He made me.
I did. The reason why is because our scenario today that we're working on is a note-taking application, and we're going to put it in context of a student going to class, a computer science class, and we're going to add AI to the application to make the life of a student easier so they can focus on their studies. So this is the application you're looking at. We'll add features such as adding images and audio and transcribing those, and then adding things like small language models and semantic search, and see how that works in here.
And as we go, we're going to add more and more experiences to show you actually how easy it is.
Right. Now, there's many ways to add AI to your application. You might be familiar with all the APIs online. You can use things like OpenAI and Azure OpenAI, or Azure has many different tools for making models or for fine-tuning models and making available as APIs.
Yeah, but in this session, what we're going to do, we're going to show you everything is running locally. And Nikola, did you turn your computer?
I did not.
Did you put it in the airplane mode?
I'm going to do it right now.
Forgetful students. What can you do? Well, anyway, so in this session, what we're going to do is we're going to show you how to add APIs, how to use APIs to add experiences to your application, as well as bring your own model to your application as well. Are you ready now?
Yes, yes.
Perfect. So, like I said, but we're going to be doing everything locally, right? So And why to inference locally? By the way, inferencing is just a fancy word that we use just to run.
Run a model.
So, you don't have to make a trip to cloud and back, so the experience is near real time. You can use offline experience. You can go completely offline if you have to, if your scenarios require that. You don't have to send your data to the cloud. So privacy is very important for many people, for many apps. And of course, inferencing on the cloud can be associated with costs, so you can avoid that.
One of the best ways to see how we're using this on Windows today is through a new feature we just announced called Recall, which allows users to recall everything they've seen on their device and go back to what they were doing. And you as developers have access to an API that allows Recall to actually surface your application exactly to where they left off and to continue what they're doing.
And Recall is running on Snapdragon Elite X that you probably heard about on keynotes and probably all day today. So another experience that also available on NPUs is Windows Studio Effects. So it's a set of really cool features that we shipped for camera and voice. And also, for you developers, what you can do, you can add controls to your application to control those effects right from your application, including Windows settings and quick settings as well.
And for game developers, we have a new feature called Automatic Super Resolution, which automatically increases the resolution for games, allowing games to render at much lower resolutions. That way, they keep the same frame rate, much better frame rate, while keeping the resolution. And this is available as part of a comprehensive super resolution suite that developers can use to bake inside of their application as well.
Another really cool thing that we announced this build is set of APIs that we shipped that you don't have to add models to your application. All you have to do is call an API and inference a model while running your application. So we're shipping 2 APIs in June, I believe. So, and more coming later this year.
That's right. Now, we've shown a lot of slides. I think it's been 8 minutes with no demo. So I'm going to show a demo.
So yeah, let's have fun. Right?
OK. So let's show you how we're actually using one of these APIs inside of our application. Now, here is that application that we just showed you. It's a simple note-taking application. Now, sometimes our professor has some things on a whiteboard you want to take a picture of. We want to make sure we include it inside of our application. Or maybe there's a syllabus, for example, that we want to take a picture of. It's paper. We want to include that as part of our application as well. It's not just about text. So in this case, Tetyana here, we sent me a syllabus as a picture.
That is not my syllabus.
That is the syllabus you sent me.
Oh, really?
Yeah. Okay. Yeah, we can just drag it over here. And we can see when we open it, we can actually select the text. We can actually do that. We can do OCR and text recognition directly inside of our application. Oh, thank you. I can't take credit for the API, but I appreciate that.
Well, he did the app. Oh, we did that.
So the code for this is actually very straightforward. This is powered by an on-device model. It's not something you ship as part of your application. It comes as part of Windows. To use it, you first make sure to make the model available, make sure that it's actually available to your application. You create a text recognizer. And then the final thing is you just call recognize text from image to sync, and you pass in a software bitmap. This is going to give you the text. It's going to give you the individual words. It's going to give you where they're located inside of the image, the actual angle. You saw inside of that image, actually, it was at an angle, and I was still able to render and build this experience on top of it really easily. So these APIs are really easy for you to use, and they can be available as part of the next Windows App SDK 1.6 experimental. And
OCR is actually one of those APIs that we're shipping. All right, so one of the examples that inside the Microsoft apps that we're using, which is OCR, is snipping tool. I use snipping tool, I don't know how many times a day.
Everybody does, right?
Everybody does. Who doesn't?
Yeah.
So in snipping tool, there is a little button. So when you take a picture now, you can actually convert text from that picture into text.
Right. And PowerToys, we just announced today a new feature called Advanced Paste. And we're adding a new functionality where you can copy any image or you can take a screenshot, and then you can paste it just as text anywhere in any application. You can also combine it with its smart converter, so that way you can ask it to convert that text or formalize that text into whatever.
Yeah, that sounds great. But we are talking here about AI.
Yeah, we've said models so many times.
So many times. Did you count how many times we actually? No?
Yeah, so many times. Yeah.
Who counted how many times we said model?
So many times. Thank you.
OK. So, but we are not talking about runway model, even though that I think this picture is really cool and I really love it because I generated it with AI, just so you know. But what is machine learning model? It's essentially a mathematical program that learns from data. So if you think about it, it's like teaching a child to solve a problem by showing them many, many examples until they can recognize some pattern that they can apply to solve a problem. Models are extremely similar.
Right. You can use them for very cool things, things like predicting when something's about to happen based on historical data, recognizing objects in videos and audio, transcribing video, audio, etc. I want to actually show you how we can do the same thing inside of our application. So if we switch back over.
Yeah. So it's time to do something else.
Right. So our professor has also made all the videos of all our classes available online. I can download them and I can watch them. It's really helpful because Tetyana and I like to skip class quite a lot.
So I don't have to come to class anymore?
That's right. So we've added all those into our notes. You can see here I have a video attached, and I open it. It also has the transcription for that video. So we have all that content. I can even play this, and it goes exactly to that spot. Now, to build this feature, we use the model called 𝗦𝗲𝗀𝗸𝗏. 𝗦𝗲𝗀 is an open source model made available through OpenAI. They've put it on Hugging Face. There's multiple versions of it. It's a great model for transcribing audio, translating audio, getting the timestamps, etc. The first thing we did here is actually getting the model from Hugging Face. And we used the tool called 𝗦𝗲𝗏 to actually convert it to ONNX format and optimize it for this machine here. You can actually see it here is where I'm referencing that model. It's just 𝗦𝗲𝗀 I'll actually show you what that looks like in my solution here. So you can see here, here's all the models we're going to be using as part of our session today.
Can
right
you
here.
visualize one of those?
We can. So for example, I can open up one of these in an application called Neutron. It's just an open source application for ONNX models. And you can see here is just an algorithm, right? There's transposing, slicing, gathering. There's different operators you can do on top of the actual data that's part of this model. You can also see the different inputs and outputs. In this case, you can see that this model takes in an audio stream here of unspecified size. You have max length, min length, different parameters they can input to it. And the output here is a string. So that's the transcription that we're going to use for our application. Usually you get this data from the model creator. You can find it on Hugging Face also. They also explain how the inputs and outputs work for these models. Now, this is a really helpful tool, but let's see how we're actually using this in our application. Now, I mentioned this is an ONNX model. ONNX is a cross-platform model format that works across many different devices and platforms. To run it inside of our application, we're using a framework called ONNX Runtime that is just a NuGet package. You can see I have it in here, ONNX Runtime. As part of that, I've just used it as a NuGet package. And the first thing we do, we actually create an inference session, and we pass in the model path, just the path to the file that we downloaded or we got it converted to use. And then when we want to actually run the model, inference the model with the data, we have to set up our inputs. And here's all the same inputs you saw in Neutron. We have the audio stream, which is just a float array with all of our samples from our audio, different things like, hey, here's where we're actually setting up the language. This model supports multiple languages. We can set we want to translate to English if it's in a different language, or we want to enable the timestamps. Once we have this, we can simply just run that inference session with inputs and then get the value of the output as a string. At that point, now we have all of the transcriptions for a model. And you saw we have multiple versions of 𝗦𝗲𝗀𝗏 here. We have 𝗦𝗲𝗏 Tiny and 𝗦𝗲𝗏 Small. The Whisper comes in different sizes. The tiny version is really, really fast, but might not be as accurate. Whisper Small is a bit more accurate, but it runs a bit slower. So you can use either one, which one works best for you, or you can even provide an option to users, say, hey, I care more about accuracy or care more about speed when I do that. And one last thing, you also notice here maybe that we use a third model for Whisper. This is a voice activity detection model. Whisper only supports up to 30 seconds, so we also use a third model to able to detect where to actually cut an audio stream, so that way we make sure we're not cutting between sentences or between words, so that way when we actually do transcription, we do proper transcription on that audio file. Now once we have that text, we can use it for whatever we want to do. We can search it, we can display it as you saw in this case. So yeah.
Sounds good.
I'm glad you liked it.
How about my file?
Your file?
Well, but where you can get those models, all different kinds of models. There are so many different places where you can get models. One of them is Hugging Face. It's actually just like GitHub for AI models. It's a place where a community of researchers put their models for everybody to use. And what's cool about it, you can also contribute to that space as well. So on Hugging Face, you not only can download the model, but you can inference and try it. Try it before you buy it, kind of thing. But it's very good, very good point. How do you get from A to Z? And there's a good session about that, by the way, tomorrow. But here, we're not going to be spending a lot of time about how to get from downloading the model to optimizing that model and get ready for your application. But I just wanted to want everybody to see that stack. From framework, and most of the developers will stay at that framework level, but then you need to use hardware APIs to be able to talk to specific hardware as well, or use DML or direct ML to, for scaling.
Yeah.
We're not going to spend a lot of time and going deeply into Onyx runtime or DML, because we have amazing sessions coming up tomorrow. For Onyx, tomorrow at 11:45, is it?
Yep.
And for direct ML is tomorrow at 2:15.
Yeah. So I hope to see all of you there.
Yes.
We have attendance, so we know who goes.
So these sessions will go deeply into this area, and will tell you exactly how to, how to convert the model, how to optimize the model, what optimization is.
Okay, so now we've shown you APIs, we've shown you models. Let's actually dive into some of the models and what you can do with those inside of our application. The first thing is about search. Now, search is kind of crucial to any kind of experience when there's content. I know myself personally, I don't like to organize my stuff. I tend to put them all in one place, and I depend on search. I know many do. So building a great search experience is going to make or break your experience. A semantic search is a way to actually search for content, not by its content, but by its meaning. You can search for something by what it means to you, not by what you actually typed or what the user said. To do this, we're going to use an embeddings model that we downloaded from Hugging Face that allows us to actually convert content into something that we can map into multidimensional space. And I know I forgot a part of a previous demo. I apologize.
Yes.
Do you want me to show that now?
Yes.
Okay.
Because
sorry.
I think it was really cool.
What I forgot to show you is actually a message that you sent me.
I know, it
that
was
I need
an
to
important
transcribe.
message.
Yes, so you sent me a message. Let's go ahead and look at that message here. I'm just going to copy it from WhatsApp. I'm going to put it inside my application, because this is a very important note that we need to make sure we have in here. There you go. So we can open it up, and it's just a quick audio that you sent us. Basically it says,
"Hey Nikola, I'm going to miss a class today. I hope our professor is not going to be upset with me, but I figured out the world #1 problem, and the solution is chocolate."
Was that worth it?
I think so.
I hope you have chocolate for everybody now.
Yes, I
okay,
do.
Great.
So if anybody wants chocolate, it's available after the session. All right, let's talk about semantic search.
So let's search. Now we have this content, we added the audio, we have all these pictures, we have all these videos. We want to be able to search for them easily. So to give you an example of what this looks like, let's say a professor was talking about number of parameters in a function, how many parameters a function can take, right? So let's search for that in a function and see what this finds. OK, so the first thing it found actually is a video where the professor says functions taking as input 0 more inputs, right? It's not, oh, thank you. It's not the text we wrote, but it's the content we're looking for, right? I can dive in directly in there. And here's where the professor was talking about functions taken
as input 0 or more inputs.
Right. So it took us right there. So how do we actually build this? Well, we use the embeddings model to take all the content in our application and get embeddings for all of it. Embedding is a multidimensional vector we can represent in multidimensional space. So for example, cats and dogs might live really close to each other when you embed them, or something else might live farther away from it, right? So it's a way to represent the meaning of content into multidimensional space. In this case, we're using 384 dimensions, which is a bit more than the 3 dimensions that we're used to, but that's how that works. In our code, I'll show you the actual search function. I'm actually going to put a little breakpoint right here. I'm going to run the exact same code as part of that. Let's see. Let's run it one more time. OK, so this is the search function. First thing that we do here, we actually get the stored vector for all the content, the vector representation of our notes, of our videos, of our images, of our audio files. And we have them stored in a database. We then get the search vector for the term that we put in. So in this case here, you can see here number of parameters in a function. And the search vector that we got for this is actually just a float array of 384 numbers. You can actually look at this. There's just a lot of numbers in here that you can see. Let's see if I can zoom in. There it is. Oh, there it is. Look.
Too much.
Big enough? Great. And then here, the stored vectors, you can see here, there's about a ton of vectors that are about the same size. You can see here this one, for example, same float of 384. What we do is, now that we have all the stored vectors, we have our new vector that we just vectorized. We can actually find the distance to the closest vectors that we have. And for that, we use a cosine similarity function. Now, I don't know the math behind this. You can ask me. I won't know it. I just use Copilot to generate it for me. It worked really well. You can see here it takes in 2 floats, and it just finds the distance between them or the angle between them, whatever the closest match is to that. So once we have that, now we know what's the closest meaning to the term that we searched. And if we continue this, we'll go back to what we just found. So it's very easy to build these type of experiences and to find content just by its meaning.
That's very cool.
Yeah.
So, in other words, to summarize, vector embedding models are just like a space map, where you put in words in relationship closer to each other. And they're pretty awesome for searching and grouping and classification.
Right.
Another really good example of semantic search would be one of our partners that we work with is Liquid Text. They built this feature, auto-citation.
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 Auto-citation, yes.
Thank you.
Yeah.
So basically, you have a note-taking on your right. It's Canvas. Yep. And the document is on the left. So what happens is that when you take in notes, it finds connection to the document on the left and annotates it.
Automatically connects them so that way you can go back.
Yeah.
And, you don't have to do that yourself. Yep. Right.
All right, so we talked about understanding text in the image. We also talked about understanding voice. We also looked at semantic search, but now is Nikola's very favorite,
my favorite
language models.
We'll talk about language models. How many of you are familiar with language models and 𝗲, for example? See, most of you. OK, for those that are not, a language model is just a model that has a general understanding of our language and how we speak or the meaning of behind that language. In fact, semantic search and embedding models are connected to that in a way as well. We can use those models to understand text, to understand language, to actually reason over text, to auto-generate additional text, and we can do some really cool stuff inside of our applications. You might be familiar with ChatGPT or GPT, which are these huge language models that exist out in the cloud. In this case, we're actually focusing on a local model, a model that runs locally on our device.
In other words, language models, it's just like super cool autocorrect from your phone on your PC.
And I want to point out that we are actually in airplane mode. I did do that.
So everything is local today.
Everything is local right here. So for example, in our application, obvious demo, I think, is summarization. I can select some text, and I can ask it to summarize this text for me. The model takes in the input that we just gave it and then gives us a quick summary of what that content is. I think this is something really cool. It runs directly on our device using the GPU that's part of here, and it's actually pretty fast. But you can do other cool things in here. For example, autocomplete. Let's say I want to type an additional note and say, Tetyana is a great what? Teacher. How about that?
Okay.
There you go. Let's see what else it says. She is patient, knowledgeable, and inspiring. Is this true?
No,
I think
really?
so. I think it's pretty true. Yeah, see? The model knows you. There you go. Or you can do things like, hey, I want to analyze the content in here and reason over it. In this case, we have a feature that we ask it, hey, what are the action items based on the notes that the user has taken? So that way, they can actually look and they can check them off. They don't have to go through all their notes like, hey, what did I say I was going to do? This automatically does that for you. In this case, we're asking the model to return them in JSON format, so that way we can programmatically render UI on top of that as well. If we look at how this works in code, we're using a new library called Onyx Runtime Generative AI. This is something we just recently released that works with a lot of these small language models that you can use locally on your device. You can actually see it right here in my packages. It's just a NuGet package. There it is. And we're using the DirectML version, which means it's actually running on top of the GPU that's on my device here as well. The way this works is you simply just generate a model, and you pass in the model files. The model files in this case, we download it from Hugging Face. They're available on Hugging Face. This is what that looks like. You just download this from Hugging Face, and you point the library to this folder, and it figures out everything what it needs to know to actually to be able to use it. And then we have this while loop here that just generates token by token. In fact, let me show you. Let's put a little breakpoint in here. Doesn't really matter where. Let's try the autocorrect again. Autocomplete, sorry. Let's try one more thing. Oh, I just hit something. Let's look what a prompt looks like for here. So here's the prompt we're actually sending to the model. In this case, we're saying, OK, system, you're an assistant that helps the user complete sentences. Ignore spelling mistake and just respond with the words that complete the sentence. Do not repeat the beginning of the sentence. And then the user says, Tetyana is a great teacher. She's patient, knowledgeable, inspiring, and then ask the assistants to complete the sentence.
So the prompt is actually a set of instructions that you give a model to follow.
Right. And the format that you saw here is just the way the model was actually trained. Different models have different formats that you can follow, and you learn that by just looking at the documentation for that model. So let's go ahead and put a breakpoint right here where we generate each token. I'm going to remove that one. Let's go ahead and get our first token. Let's see what it hits. So we can see here, our first token is just, is that a T? That looks like a T, right? In this case, it's just a letter T. We hit the next token, it's Eddie. So Teddy? Let's see what the next one is. Tetyana. Oh, it was spelling Tetyana. So it actually, you see how it works. It actually responds token by token, and tokens are usually just parts of a word. And that's how you actually see it streaming the content to your application. It works really, really well. That's it. So those are small language models. Oh,
So that's cool. We already learned about language models, but you probably heard about LLMs, SLMs. What is the difference between SLM and LLM, or small language model versus large language model? The difference is the size. And what those models are developed for. So I like to say or think about as PhD student versus high schooler. PhD student has a deep knowledge in specific area, versus high schooler has a basic knowledge, but a lot of different subjects, right? So the difference between SLM and LLM is very similar. So SLMs are smaller models, but can be trained further.
There's ways to make these models actually do what you want them to do by providing additional data to them.
Absolutely. So there are some techniques that we can use to introduce additional data to the model. One of them is RAG, or Retrieval Augmented Generation. So think about, I mean, I know that I'm using a lot of examples, but this is how I like to think. So think about a huge library of books. And you need to find information in one of those books really fast. So you need a really skilled librarian. Go and get that information fast for you, but you also need a teller that will represent information in a very meaningful way. So my librarian is retrieval, and my storyteller is generation. But also, you have the library of books to add to your model.
Right. Yeah, this is an easy way to ground the model to actual truth. Instead of just letting the model use its general base data that it has, you can actually provide it the data that you want it to work on top of, so that way you can guarantee that it's actually grounded to that data that you have, either it's your customer's data or your personal data that you want to use the model on top of. So we actually have a demo.
Yeah, I think we have an example with RAG for our application.
Right.
Let's see.
So we can put the two things. Oh, I'm still debugging. Let me stop that. So we can actually combine the two that we just talked about. We can combine semantic search and small language models to actually create this RAG experience. For example, here we have a little robot, and I can ask it, we haven't been going to class like I mentioned because we're great students. So we want to know when are office hours, like we need to go and catch up. So we'll just ask when are office hours, let me just spell that, hours for CS10. CS10 is our class. Let me just remove that breakpoint for search.
Is it computer science class?
There you go. So you can see the model response with the office hours for CS10 are on Tuesday from 10 a.m. to 11 a.m. They provided some additional information there and told us we found this information in this specific video. It takes me directly to where the professor is talking about, and my office hours this week start half an hour early, tomorrow 10 a.m. to 11 a.m., right? So well, thank you. Go ahead, Clive. Thank you. I appreciate that. So we combined the search, right? The skilled librarian to find the content we need really quickly, and then we pass that content over to the storyteller to actually explain it to us in nice words, so that we don't have to go in and do that ourselves. So the way this works in code, you can actually see it right here. We put a little breakpoint. I'm going to do actually, I'm going to try a different one. I haven't tried this, so this is going to make Tetyana nervous. I'm going to search for your audio file. What was the answer to the world problems, I think, is what you said? Because we added that just now.
I'm very confident, so I'm not nervous.
What is the answer to the world's problems? Let's see if this works. OK, so we can see here before we actually send this to the the SLM, 𝗲, first things we do, we find the content, we do a search. So in this case, OK, it actually did find your text, right? It found the text that I was searching for and said, OK, here's the content, here's the question that the user is asking. Oops. Is what is the answer to the world's problem? I know you can't see it here, but there it is. And then we generate a prompt to the SLM. So and here we can look what this prompt looks like. Let's open it up. And we can see here, OK, you're a helpful assistant answering questions about this content. And we just passed the content that we found, that the application, the semantic search found. And then it passes the question from the user is, what is the answer to the world's problems? And then if we answered, and we let this go now, while chocolate can certainly bring joy and happiness to many people, it's not a direct solution to the world's problems.
That's exactly my point.
And it just answered it. And then we can go directly to where that is. There it is.
That's pretty cool.
Yeah.
So another technique that you can use is fine-tuning. As I mentioned before, SLMs are base models. They are not trained for specific tasks. Your scenarios might require some of the specific tasks that those models can be applied to. And fine-tuning will help you there. It's not retraining the model. It's training model further. It's adding additional data that will train the model or teach the model for a specific task.
Right. A great example here I like to use is the autocomplete example that we showed you earlier. For autocomplete, we just use the base model with just the knowledge that it already has. But you could fine-tune that model to speak like you or to use terms that you use in your organization just by providing it lots and lots of data and fine-tuning on top of the model to be able to know how you're typing and what you're trying to say here instead of just inventing new things after the sentence you've written.
No, absolutely. Yeah. So there is a tool, great tool, that you can use to fine-tune models locally. We call it a toolkit for VS Code. It's an extension to VS Code, and you can browse a model catalog of models, download that locally, but what also you can do, you can play with them, you can try them. We have a model playground where you can provide a prompt, and you can see how model respond. So if the result is not what you're looking for, you can actually create your data set and train a model further. So to do that, what you can do, and actually, in my example here, I like to play tennis, which I do, and it recognized that it's a joy for me, right? So to fine-tune it, it basically creates a project. So you need to set up your project. You can choose your data set. You can choose data set that we already built for you to test. And you create a workplace where you can continue fine-tuning the model using simple Python scripts.
There's actually a couple of great sessions that are going to go over this specific thing. There's a session called Zero to Hero, that's happening, I believe, Thursday. Yep. And there's a session that's happening tomorrow that's talking about 𝗲𝗏 and how to actually fine-tune it as part of the Onyx runtime session as well.
Yeah, absolutely. All right. So, working with AI can bring joy. As you can see, we built this amazing app with you for, we don't need to go to classes anymore. We can just download.
We graduated. We got a degree.
Yes, we graduated. We can just take the voice recording of lectures and just have all the context, summarize it, and do all the cool things. But, we have to think about responsibly applying AI. And, when we build a new model in Microsoft, when we change a new model in Microsoft, it goes through very thorough reviews. And we call it responsible AI reviews. There are multiple principles that we follow, make sure that it doesn't bring harm to our customers. So when you develop new applications, you might also want to keep in mind that AI can bring joy, but also it can bring harm.
Right. With great power comes great responsibility, as somebody really important said once. But what's important is that when you're reaching so many users and you have these capabilities here, it's very important that you are doing this responsibly and you're using a lot of the tools that are already available to you to make sure that whatever is generated is safe for everybody to use, or whatever is being passed to the models, you clean it up, just like you do with SQL, just like you do with everything. You make sure you do your homework and make sure you do the right thing.
Absolutely.
Yeah.
So thank you for coming today. We do have number of sessions coming up that go much deeper into the subject that we touch base on. We definitely recommend you to check them out. And some of the sessions tomorrow and some of them on Thursday. But if you have any questions, Nikola and I will be around.
Yeah.
And I'm sure, I'm not sure if there are questions online. We're happy to answer.
Yeah. And we have plenty of experts here. The code that we just showed you is also available online as well. You can go check it out right now. You can play around with it as well. Thank you.